Well, if you've seen the film Interstellar, you probably have some questions about why it would be that Matthew McConaughey's character, who flies away on a ship at a very, very fast velocity towards a distant solar system far, far away, ages for only 1 hour for every 7 years on Earth, and upon return finds out that his daughter is older than him. And one way to understand this, as outlined by Einstein's special theory of relativity, and there's also some general relativistic effects, is to first start by looking at the relative velocities of your twin on a ship, known as the twin paradox. So we're going to play around with the twin paradox. If you imagine you have your clock on your ship and it ticks by sending a light beam down, up in a periodic fashion over some period of time, then that atomic clock ticks at a rate to measure time based on the distance traversed up and down by this light beam reflecting between mirrors. That distance over that time interval travels at some velocity, and that velocity is the speed of light because it's a bouncing light beam. However, if your twin on Earth is observing you flying past on your spaceship, they do not see that atomic clock to move up and down in a vertical direction. Rather, as you fly across, that downward motion of the atomic clock now stretches so that instead of traveling down, they see the light beam travel at this diagonal distance, depending on your velocity, and bouncing back up, reflecting up that diagonal distance as opposed to that vertical distance. Therefore, instead of traveling some vertical distance, it travels a much larger distance. So you have increased the distance that you observe that light beam to travel as viewed from your twin who is fixed on Earth. That increase in distance traveled, however, must travel at the same velocity because both observers must agree that the speed of light travels at the speed of light. You can't measure the speed of light at some other velocity. Therefore, for whatever increased distance that light beam travels, it must increase the amount of time it takes. Therefore, a person on Earth will measure your light beam, your time, to be much longer to cover that distance, whereas on the ship, you will age at a much lower time. Now, as your velocity approaches the speed of light, the effects of this time dilation increase. Therefore, as you get faster and faster and faster, from the perspective of Earth, the amount of time appears to approach zero as it slows. Okay, we'll pause there. Take a look back.